Okay, so we're going to be starting a new chapter, chapter 7, and it's all about proof and conditional probability. So what we're going to be talking about is proofs, right? And so we've already talked about proofs before when we were trying to prove, that triangles were the same by using like side, 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 congruency, or side, angle, side, congruency, angle, side, angle. So remember we kind of made these lovely flow charts with one of these 5 different congruency statements. Okay, so we're going to explore some more proofs. We're going to get into something known as a 2-column proof. And so one of the first things we're going to do is we're going to talk about quadrilaterals. So let's take a look at this first question. And again, this is just exploring. We're going to come up with a conjecture, which again is just kind of a guess of what we're saying, and then eventually we'll prove it true, or we'll write down our proof. All right, so Carla knows that a parallelogram has 2 pairs of parallel sides, right? So if I drew a lovely parallelogram, right? So let's pretend that this is a parallelogram. What we're saying is 2 sides are parallel. So that's our parallel symbol, and then this double parallel symbol. So this side is parallel to this side is parallel to that side. If we label them, right, A, B, C, and D, I can say A, B would be parallel to DC, right? So AB's length to DC. I could also say that AD is parallel to BC and things like that. Okay. She has studied special properties of isosceles triangles. So isosceles meaning 2 sides are exactly the same. And she wonders if parallelograms have any other special properties. So she remembers that it is possible to create a quadrilateral that looks like a parallelogram by rotating a triangle around the midpoint of one of these sides. Okay, so if you want to try this on your own, right, pause the video and kind of copy this to the best of your ability onto your paper. And what we're going to do is we're going to rotate it, and we're going to rotate it around this line right here, and we'll rotate it around what we think roughly is the midpoint. So go ahead, try it now. Make sure that you have the lines marked for the angles, because those are going to be important. And then when you come back, I'll show you kind of what it should look like if we rotated it. All right, so again, we're going to visualize rotating it. And so if we rotated this and we were to create a second triangle, probably something like this, okay, this angle right here would match up perfectly to right here. This double angle would match up perfectly right there, and then this angle down here would match up right there. So we've rotated our triangle to make a quadrilateral that looks like a parallelogram, because again, this side is going to be parallel to that side, and then this side would be parallel to that side. So is Carla's quadrilateral truly a parallelogram? We want to use the angles to convince our teammates, or convince me, that the opposite sides are parallel, right? So what do I notice? Right, we have to remember that if we have a set of parallel sides, right, then this means that this line right here is our transversal. And if our transversal cuts 2 parallel lines, then we know alternate interior angles are congruent. So yes, right, it is a parallelogram since we have pairs of alternate interior angles that are congruent. So if we say this, so since we have pairs of alternate interiors are congruent, opposite sides must be parallel. Okay, so important important things. What else could we look at for properties of a parallelogram? Well, it kind of also like reminds you of like a rectangle on its side a little bit. So if this side is the same of length as this side, and this side is the same of that side, right? We can also say, you know, opposite sides are the same. So we can say opposite for this one, opposite sides are congruent. We can also say opposite angles, right? So this angle right here, right, and this angle right here are also congruent. So we can say opposite angles are congruent. And it actually also works with this guy right here. So say that this was, I don't know, 20, which means that this will also be 20, and say that this is 30, which means that this will also be 30. So this would be 50, and this would also be 50. So again, if we actually put numbers in here to kind of think of what's happening. Okay, so again, we're just exploring some parallelograms, right? So let's continue to the second problem, right? So problem number 2. So definitions are one of the building blocks of our geometric proofs, right? So if we don't have a definition, right, then we're not going to have a good proof. So we definitely want a definition. So our definition of a parallelogram says this: a parallelogram is a quadrilateral with two pairs of parallel sides, right? That's what we want to use. So definitely copy down. Right? The definition of a parallelogram is two pairs of parallel sides, right? So we can definitely use that information, okay? So if we look at this, we can start using that to prove other properties. Does the diagonal of a parallelogram always split our quadrilateral into two congruent triangles? So just like on this one, these were two congruent triangles. So we want to draw a diagram at your right on your paper. So if A, B, C, D is a parallelogram, what do you know must be true about that definition? Okay. So let's think of what we know. Okay. So I know that this is a parallelogram. What do I know about the parallelogram? I know that it has two sides that are parallel. So I know that this side is going to be parallel to that side, and I know that this side is going to be parallel to that side. So I'm going to start off, I'm going to make a flow chart, right? So let's kind of jump to part B and create a flow chart. So the first thing I'm going to do is I'm going to state what was given. What's the first thing I gave before I even drew on here? This was a parallelogram. So I'm going to say A, B, C, D is a parallelogram. Bam. Okay. Why do I get to say that? It's given information because I gave it right here. Based on this information, what were we able to conclude? We were able to conclude that these two sides are parallel and these two sides are parallel. So based off of that, I'm going to say that AD is parallel to BC. Okay, and then off of this side, I'm going to say that AB is parallel to CD. Now, why do I get to say that? Because I used part of the definition. So I'm going to say definition of a parallelogram. I'm going to use the same thing. So def of parallelogram. All right. So based off of your parallelogram, right, what we kind of did on this previous problem, I noticed that alternate interior angles are congruent. So based on this guy right here, so if AD is parallel to BC, that means ADB, so this guy right here, is going to be congruent to CBD. So I get to say that, right? So I'm going to say angle ADB is congruent to CBD. Bam, arrow. And why do I get to say that? Alternate interior angles, right? Because of the parallel lines. And then this also means that for this guy, let's do it in black. So that means, oops, sorry, I don't know why I drew it there. I meant to draw it here. That means that this guy is going to be there. So I'm going to draw a little arrow, and so I'm going to say angle A, B, D is congruent to C, D, B, and again, definition of alternate interior angles because they're congruent. Okay, so all of a sudden I have two angles and I have two angles in common. So if I go back to the first thing that I talked about, right, I'm going to use my two angles. I'm either going to say angle side angle or angle angle side. So on this one, if it was angle angle side, I'd have to use either this side or this side. And I don't know that side. What I do know is I do know that BD connects both of these together. Right, so our last piece of the puzzle, which doesn't have to do anything with the parallelogram, so I'm just gonna kind of put it off to the side. I'm just gonna say that BD is congruent to DB. And why do I get to say that? I get to say because it is your segment congruent to self, or I can say or reflexive property, right? Either one, perfectly fine, right? Here's my angle, here's my side, here's my angle. So last but not least, I'm going to put all of this together. So I'm going to say that this and this and this leads to my two triangles. So my two triangles, I would say that triangle ADB is congruent to triangle CBD. And I'm going to say angle, side, angle, congruency, right? So now I proved my two triangles are congruent, again, using my definition. If we continue on part B, extend your flowchart proof to prove that opposite sides of a parallelogram are congruent. So remember, once your triangle is proven that they're congruent, that means all sides are congruent, all angles are congruent. So even though we didn't talk about angle A or angle C, right, I would get to continue. So basically what I get to say is that the line segment AB is going to be congruent to CD, right? So AB is congruent to CD. And why do I get to say that? CPCTC, congruent parts of congruent triangles are congruent, right? And then over here I get to say AD is congruent to CB. And again, same reason, CPCTC, or I can draw it out in pictures. So congruent triangles therefore have congruent parts. So either one, these mean exactly the same thing. So again, we're just kind of playing around with flowcharts. Now, what happens in this original picture if I didn't rotate it? What happens if I kind of just flip this over this line? If I flipped it over this line, I would have created a kite, which is not a parallelogram. Okay, so what transformation did Kip use to create this shape from part one? Right, he reflected it, so reflection, right, across one side. And what shape did he make? So there is a methods and meanings box in this lesson, so just go online to look that up. He created a kite, right? And kite has two pairs of adjacent sides that are the same length, right? So that's kind of our reasoning. What do our congruent triangles tell you about the angles of this polygon? Well, if you look at it, right, we can say that at least one pair of opposite angles are congruent. So these are opposite pairs. So I'm going to say one pair of opposite angles are congruent, right? And what do the triangles tell you about the diagonal? They bisect. So bisect angles, because again, notice that this angle is the same on this side and this side, and then these two are going to bisect our bottom our bottom angle. Does not mean that they are congruent.